Hey, what's up everybody? This is Ray and welcome back to our Objective-C video tutorial series. In this video tutorial, we're going to take a look at blocks. Okay, so as you saw in the last video tutorial, here's a typical problem that you run into when you're working with delegates. So you have an object and you set yourself as the delegate to this object so you can receive callbacks when interesting events occur. And then you tell your object to go ahead and do something, and this might take a while. In iOS development, for example, it might be that you're making a network call to a remote web service. And when it completes, you're going to get a callback method on your delegate. And so now you have a problem. You have your code to sort of kick off a task in one spot and your code to do the next step of your task in a different spot. So it just makes your code a little bit hard to follow. And so blocks, one of the advantages of blocks, and there's many other advantages too, is that it helps you keep your kickoff task and your completion handler code all in the same place. So here's an example. Don't worry about the syntax yet, we're going to review it. But you say my object do something, and you see this little caret that's sort of saying here comes a block, and you have a function that is going to be called when it completes. In other words, what blocks are is they're anonymous functions, which you might have used in other languages. So you're basically defining a function in line that will then be called later on. And one of the coolest things about blocks is you can actually access stack, which are local variables, and also heap variables from within your block. You can do a lot of cool things with them that way, as you'll see in some demos. And blocks are really important to understand, even though the syntax gets a little confusing at first. They're really important to understand because they're used all over the SDK and they really make your life much easier as a programmer once you get used to them. Okay, so let's take a look at the syntax to declare a block. Now in this example, what we're doing is we're creating a variable in which is going to store an anonymous function that we can then use later. We'll look at other ways of using blocks a little bit later on. So first we say, what's the return type of this function? Okay, then you put the special caret mark that means, hey, this is a block. And then inside parentheses, you give the variable name for the variable you want to store this block in. And then you give the list of arguments one after another with commas. Then you say equals. So the left-hand side, you can think of this left-hand side as I'm declaring the type of the variable. And then the part on the right is I'm defining the actual function. So defining the actual function, you give the caret again to say, hey, this is a block. The list of arguments, same as before, but this time you do have to give them argument names. And then finally, in brackets, you give your method implementation just like you normally would. So on the bottom of the slide, you see an example. This is the return type is void, it means it returns nothing. The name of the variable is going to be called myBlock, and it's going to take an ID, an integer, and a Boolean pointer as arguments. And none of those need to be named on the left-hand side. On the right-hand side, you give the caret again to say it's a block, list out the arguments again, but this time they do have to have names. And then inside the curly braces, you have the implementation of your method. And all this particular block does is it logs out each of the objects that are passed in as a string with a string video game beforehand. And here's an example of using a block is video games is a NSArray, which you'll learn about in another video, but it has a method on it called enumerate objects using block. And what that does is it goes through each of the objects in the array and calls the block on each object in there one at a time. So your method that you wrote here, myBlock, it will be called 3 times in a row or however many times based on the number of elements that are inside the video games array. So that's kind of the first way of using blocks. Now, what we did last time is we created a variable to store the block in and then just passed that variable in as a parameter to the enumerate objects using block method. Well, if you want to do a shortcut, you don't need to define that variable at all. You can just create kind of an anonymous variable inline that you pass into the enumerate objects using block function. So basically here it's the exact same as before, except we've taken off the left-hand side. We basically pasted the right-hand side into the enumerate objects using block method. Now the reason I'm showing you this way is this is actually the more common way of doing things when you're doing iOS development, just because it saves a step and it's a little bit easier to read, I think.
Okay, so let's have a play with blocks. As always, I'm going to create an iOS application, single view application template. I'm going to call this block test, and I'll just save this to my desktop. Okay, so I'm going to create a class to run all these block tests in. So I'm going to create a new class with the iOS Cocoa Touch Objective-C class template, and we'll call this block tester derived from NSObject. And this class is going to have a single method called runTests. And we'll just start adding the code here. So our first test, we're just going to declare and call a block inline. So remember the syntax to declare a block. So you give the return type of the block, which is going to be, in this case, returning nothing. And then you, in parentheses, you put the caret, which says this is a block, and you give it a variable name. We'll call it myBlock. And then you give it the list of parameters. So this is going to be the same example from the slide. It's going to take an ID, an NSU integer, and a Boolean pointer. And then you say equals, so basically myBlock equals, and then use the caret again to say this is a block, and then you list out all of the parameters again, but this time with names. Call the first one obj, and then index for the second one, and the last one will be stop. And then inside these curly braces, you put the implementation of the block. So basically, we're creating a function here, but inline, and we can reference this function by a variable name, myBlock. And then what all this is going to do is same as in the slides. We're just going to say the video game is, and then we're going to cast the object that's passed into a string and just pass that out. Okay, so now that we have this variable that has a function pointer basically in it, we can call this whenever we want. So if I wanted to call this, I could just do myBlock, and in parentheses, I'd pass in all the parameters here. So remember, it takes those three parameters, the object, the index, and stop. So I'll pass in one of my favorite video games lately, which is called Path of Exile. And for the index, I'll put in 0, and for stop, I'm going to put, we'll use a Boolean pointer, so equals no, and then we'll just pass in, actually, let's see here. It's actually going to be setting that, so I need to pass in the reference. Stop. Okay. And we'll call this creating and calling a block test number 1. Okay, and let's try this out. So I'm going to go to application did finish launch with options, and we're going to import block tester, and then I'll create a new block tester and just call run test. And we see here that it ran our code, video game Path of Exile. Okay, so far so good, but you might wonder, why would you ever want to do that? For this, I was just basically trying to show you all blocks are is really pointers to functions. Okay, so now I want to show you how you can pass a block to a method. So this signature for the block here is actually the same signature that gets passed in enumerate objects using block. That's why I chose those parameters. So let's use it for that. So let's say we have an array of video games. And let's list out a few more games I like. And I'm going to use the literal syntax here to create an array with 3 strings in it. And they're going to be Fallout 2, Deus Ex, and Final Fantasy IV. And then if I want to enumerate these objects, I just do video games, enumerate objects using blocks. And using block, you can see here in the auto-completion the parameters that it wants here are the same as what we define here. So that block is compatible. So I'm going to select that and pass in my block. And it's complaining because I forgot to put the @ sign here. And this second test is passing a block to a method. So I'm going to go ahead and run this, and you can see that now the block that we've created here has been called 3 times, one for each of the elements inside the array. So this code here has just been called 3 times. And for the last thing I want to show you is I want to show you how to use the sort of shortcut inline form of writing things. So instead of sort of creating the block here and then passing it in here, we can do everything all at once. So we could have said video games, enumerate objects using block. And I'm just going to enter to autocomplete this and close that out. And inside here, I'm just going to copy this exact line of code here and paste it in. And I run that, and you see that it runs the exact same way as before, except this code is a little shortened. And actually, this is the way you'll see most often when you're working with blocks in iOS development. Okay, so far the examples that we've looked at have been cases where we created a block and then we called a function that used that block right away to do something. So in this enumerate objects using block, it's going to call this block right away for all the elements inside the block. But I want to show you one of the coolest things about blocks, in that you can actually store the blocks in a property for use later that you can then call later. And that's where they really become powerful. So let's take a look at that. So let's say we want to store a block away to be called later. Well, we need to store it in a property. So I'm going to create a private interface here. And inside there, I'm going to define a property. And it's going to be non-atomic. And for the type here, you can use strong or weak or copy. But for blocks, you always want to use copy. This is because when you create a block, by default, it is on the stack. But if you want to store a block for usage later, you need to move the block to the heap. And the way you do that is by using the copy semantic. So I'll choose that, and then we're going to declare the block here. So remember the syntax for that: you first give the return type, and then in parentheses you give the caret to say it's a block, and you could give it a name here, but you don't need to, and then the types of the parameters. Okay. So I was wrong. Sorry, you do need to give the name there, and this is the name of the variable or the property. Okay. So we have a block property that we can store a block in for later. So what I want to do now is create a method here, and it's going to call do something with block, and it's going to take as a parameter a block. So it's going to return void. It's a block and an integer bool star, and we're going to call the parameter block. And then what we want to do is we want to store the block that's passed in inside the property so that it is copied for use later. And then we want to simulate, the fact that this function is doing something. And in a real-world app, it would be maybe doing something over the network or a long-running operation or something like that. So we'll say self-perform selector. There's a method here called perform selector with object after delay. And that will do as you think. It will call a method after a particular delay. So we're going to choose that. And when you give a pointer to a method inside something that asks for a selector, you have to wrap the name of the method with the selector keyword. And we'll get to that in a future video. But 1 second. And then if there's any parameter that you want to pass into the object, we won't pass in anything. And then 1.0 seconds. And then after 1 second, what this is going to do is it's going to call the block. So self.block. And just like in our earlier example, you can pass in whatever here. So we're just going to copy this bit of code right here. And we'll pass in a different game here. And last but not least, to test it, we're going to call self do something with block, and we're just going to implement that here, and we're going to just have this be done. So I ran that, and you might have seen that after a second, done popped up here. Okay, so what we did here is we created a block right here of code. And right here, that block of code was copied and stored inside a property. A second later, that block was called with the string The Legend of Zelda, and right here it just logged out that it was done. And this is a pattern you'll see a lot in iOS development, because you'll create a block of code that will be run by Apple iOS code whenever the operation that you're trying to get it to do completes.
So as I mentioned earlier in this video, one of the greatest things about blocks is you can access variables that are outside the scope of the current block. from within a block. So here's a list of everything you can access. First of all, you can access global variables from inside your block code. You can access the parameters, obviously, that are passed into your block. You can pass in stack variables, and this is where it gets particularly interesting. What I mean by stack variables is, say, the enumerate objects using block method we've been discussing so far. So if you were to have a local variable before that, you could actually access that local variable inside the block, and you could, use that value. And actually what it does is it makes a copy of the value inside your block. But if you use the __ block keyword, you can actually reference that same value by reference instead. So that's really cool because you can then update that local variable inside your block, and then after the code executes, your local variable will have been updated. We'll see an example of that in a minute. And then finally, of course, you can access any local variables you create within the block itself.
Okay, now let's play around with trying to access variables from inside blocks. So in this inline form here, all we're doing here is logging out the name of the video game. But what if we wanted to modify this to log out something different if it's our favorite game? So let's say we have a local variable here that stores our favorite game. And my favorite game of all time is Fallout 2. So now inside here we can actually access that variable. So we can say, let's get a reference to the object as a game. So we're just going to cast obj as an NS string. And then we're just going to say if game is equal to string favorite game, then we're going to log something special. Otherwise, we'll log the same stuff as we usually do. So the special thing is woot, this is my favorite game, and then just pass in game there. And I run it, and I see woot, Fallout 2 is my favorite game. So that's pretty cool. But what if we want to do something else, where let's say we wanted to keep track of the count of games. And let's say we want to initialize that to 0, and let's say every time inside this array we want to increment the count of games. Okay, well you see right here it gives me an error, and it says variable is not assignable missing block type specifier. That's because of what we just discussed in the slides. It's fine to access variables, local variables like this, for reading purposes because it just makes a copy. But if you want to be able to write back to the value, like in this case, you have to mark them as __ block. This effectively moves that variable to the heap, so you can use this value by reference and update it later. So it updates the count of games ++. I put the __ block keyword before that, and now I just log it out, count of games. If I run that, I see that the count of games is 3. Okay, the final thing I want to show you is how you might have a retain cycle inside your code that uses blocks. So say in this, do something with block, then we're logging out done. Say we didn't want to actually have that code inside there. Say we actually wanted to have a method called log done. And that would just do that. So instead we would say self log done. So it looks like it works, right? Let's try something. I'm going to write a dealloc method, and I'm just going to write deallocated there. That never gets called. That's kind of odd. Let's try something else. I'm going to comment that line out and run it again. It does get called here. So something's going on here where it does not get called. And we can even prove this by running product profile, selecting the leaks instrument. And if I select leaks and tell it to snapshot, I see a leak here. And there's actually a cool option here where I can choose cycles and roots. And I see it even shows me where the the retain cycle is going on. So something is referring to, here's a block, and it's got a reference to block tester, and block tester has a strong reference to the block. So what's going on here? So what's going on is, remember how I said whenever you call a method on self, the block needs to have a strong reference to self in order to call that method, of course. And when you call do something with block, self is also keeping a strong, copy reference to that block. So that's where the retain cycle is going on. So the workaround is what we do here is we create a weak reference to self by using the weak keyword. And this is a block tester object. So block tester, we'll call it weak self equals self, but it's now a weak version of self. And so instead of calling self log done, we can call weak self log done. And now if I run this, we get deallocated right here. And if I were to run the leaks instrument, we would not see the retain cycle anymore.
All right, that's it for this video tutorial, but as always, I want to leave you guys out with a challenge to try this on your own and play around with some blocks. So the idea behind this challenge is Vicky has been sick for the past couple days, sadly, over here. And so what she does is when she's in bed feeling bad, she actually text messages me when she needs something. Well, so she says, I need some soup or I need some orange juice or whatever, and then I go and bring it to her. So we're gonna make a block-based callback that simulates this. You're gonna be Vicky and you're calling methods on Ray to make different orders to come to you. So I have actually created some classes for you. One's called order, and it's very simple. All the order does is it keeps track of what you're trying to order and the block that's going to be called when it's complete. And then I created a class called Ray, where you can call this method you see right here, order with completion handler, and it will go ahead and after a second, it will perform that order and call back the method you passed in. So what I want you to do is write some code to call the Ray class and make a few orders. You should order some soup, some orange juice, whatever you might need if you're feeling sick. And when the completion handler is called, I want you to check the status of that completion handler and just log out something different based on success or failure. This will give you a little bit of syntax with blocks, but in addition to just writing that code, it should be fairly simple. I want you to look at all the code I've added for you and make sure you understand everything that's going on to get a feeling for how block syntax works, as you'll be seeing this a lot in the videos to come. Hope you've enjoyed this video tutorial. Thanks for watching, and we'll see you next time.